So a block has been placed on a curved inclined plane and we have to find the maximum height till which the block does not slide. So first of all, we need to understand the visual of the problem. Now if the first step is visual. So this is a curved rough surface. Let's say the mass is lying here at the bottommost point. Now in this situation, friction does not need to make any effort because the normal force is taking care of the gravitational force. But as we start moving the mass, now at this point, the mass has tendency to slide and so friction will come into picture. Let's say the force is F1. You can intuitively feel that as this mass moves upward, the friction force required to hold this block in this position will increase. It will keep on increasing as you push the mass. And there will be a maximum height h, after which the block will start sliding. The friction force is maximum that the surface can apply, but it is not sufficient to prevent the mass from sliding. Okay, so we have to find this height. Now the second step, once we have understood the visual, is to draw the FBD. The free body diagram for this is pretty simple. This mass is experiencing mg force downwards, a normal force which is perpendicular to the surface away from the surface, right? And there is a friction force which is maximum in magnitude. So let's extend this line, and this line is making an angle theta. Now let's just focus on the incline. Okay, this is angle theta, this is the mass, this is mg. Let us break down this force of gravity. This component sine theta and this component is mg cos theta. So the friction force, this maximum friction force, is actually balancing out the mg sine theta. So we can write F max is actually equal to mg sine theta. Now what else do we know? We know that the maximum force that the rough surface can apply when the block is stationary is given by mu into n, where mu is the coefficient of static friction and n is the normal force. Now how are we going to find out n? From the force balance we can see, since this component of mg is mg cos theta, this is being balanced by n. So n is mg cos theta. Now let's use both this information. Mu into mg cos theta is equal to mg sin theta, or mu is equal to tan theta. Now a lot of us already know this, that mu is called tan theta and this is called angle of repose. But I was trying to explain from where this expression is actually coming from. Now how do we find tan theta? See, in the problem mu is given to us, but we don't know tan theta. So if you carefully observe this curved surface, this line is actually tangent at this point where the mass is kept. And we have the equation of this, y is equal to x square by 4. So to find the tangent on this curve, we differentiate it with respect to x. So we get dy by dx is equal to 2x by 4, or this is equal to x by 2. And dy by dx is nothing but tan theta. So, and this is given to us as mu. So we can write 0.5 is equal to x by 2, or x is equal to 1. We have the value of x, so we can find the value of y, which is x square by 4. So this is 0.25.